Okay, now what we're going to do is actually look at a way you can solve a quadratic equation. Of course, that's what we've been talking about this whole time, is dealing with quadratics. And again, if you remember, a quadratic is anything or any expression or any equation in which your largest exponent is to the second power. And actually, the remaining part of chapter 4, which will be on the second part of your test, or be on test 2, will be some other ways that we're going to learn how to solve quadratics. But this will concentrate on just the factoring. All right, so an important note here that I've given you, it says that your equation needs to be set equal to 0, and you need to arrange your terms in descending order. Of course, that means from your largest exponent down. So it'd be like a second power, your first power, and then last would be your constant. So that's what I've got to do to this first example, is actually just basically rearrange my terms a little bit here. If I need this to be set equal to 0, that means that I need to subtract my 9x. Now that's not going to combine with either one of these terms though, because they're not like terms, but you would want to put that as your middle term, because as I mentioned, you want this to be in descending order. So second power, first power, constant, okay? Now, once you get that taken care of, then you do your factoring. Now, remember, when you're factoring, if you have a GCF, then you do need to, check for that first. But I don't have a greatest common factor here. Just go ahead and set up your two parentheses. So x squared would be x times x. 18. Of course, you have a choice of 1 times 18, 2 times 9, 3 times 6. But if we're trying to get a negative 9 in the middle, probably 3 and 6 is what we need to use. And it doesn't matter which one you put in which set of parentheses, since the first terms are the same. Now remember, we learned that if this is positive, that means my signs down here have to be the same, and you would have to add a negative 6 and a negative 3 in order to get your negative 9. So once you get it factored, then you're going to use what's called the zero property product, and that just means that you take each of your factors and individually you set each one of these equal to 0. And of course, you have just a one-step equation to solve. Here you would add your 6, therefore you get x equals 6. Here you would add your 3, and you get x equal 3. Now you can always check your answers anytime that you want to. Like on test, if you're just wanting to double check it, because you can, substitute the 6 back in and make sure it checks, and then come back and substitute the 3 and make sure that it checks. Okay, example 2. Okay, again, first of all, I need to take care of just the arrangement of my terms. I do need to have 0 on one side, if you remember. And the quickest, of course, would just be this term shifted here. But remember, when you're factoring, you're going to want your x squared term to always be positive. So since it's positive, I'm going to leave it on the left-hand side, which means both of these need to be shifted to the left. So that would require that you subtract the 16x and subtract the 12, which would then leave you with 0 on that right-hand side. Okay, doing our factoring. Okay, now I don't have a choice with my first term but to go with 3x times x. Now with 12, you've got a few choices there, because you've got 1 times 12, 2 times 6, 3 times 4. So I'm just going to use a pencil for just a minute, so you might not want to write it down until we get the right combination. If I were to try 3 and 4 first, if you remember on the previous lesson, I told you not to put numbers together that have factors in common. So like, I don't need to put the 3 in here and have 3's, because they have a 3 in common. You're not supposed to do that. So I'm going to put the 4 here, and I'm going to put the 3 here. Okay, so let's make sure that that gives me what I need. All right, so if I multiply these two together, I get a 9. And then if I multiply these two together, I get a 4. But there's no way to take a 9 and a 4 and get that negative 16. So that's actually not what we need to do. Okay, so now let's try the 2 and the 6. But you don't want to put the 6 and the 3 together because they have a factor in common. So I'm going to put the 2 here and put the 6 here. So now if I multiply these two together, I get 18. And I multiply these two together, I get a 2x. Okay, now that seems to be what I'm going to need because I can use this to get that negative 16. So I'll come back, put a 2 here, put a 6 here. I am supposed to have different signs, but to get negative 16, I would need a negative 18 and a positive 2. So that means minus sign needs to go here, plus sign needs to go here. Now once you get it factored, and that's the hard part of these, is just getting them factored. So now I take 3x plus 2 equals 0. So 3x would be equal to negative 2. So x is equal to negative 2/3. Okay, so there's one of my answers. And then I would have x minus 6 equals 0, which is going to give me x equal positive 6. So there's another answer. Okay, next one. Now on this one, it's already set up the way that it needs to be set up because it is in descending order. I don't have the constant term, that's fine, but it does go from largest exponent down, and it is set equal to 0. Now if you remember, the first thing you're supposed to do whenever you're factoring something is to see if it has a common factor, and these two terms do have a common factor, and that would be 2x. So if I were to factor 2 from 6, that leaves me with a 3. I have 2 x's, I'm taking one out, so I've got an x left. And then taking the 2 from the 4 would leave me with a 2, and I won't have any x's left. And that's actually the only factoring that you have to do on this one, is just GCF. So you take this factor, I mean, even though it's not in parentheses, it's still considered to be a factor. So you would do 2x is equal to 0, and 3x plus 2 equals 0. All right, so divide by 2. Of course, 0 divided by 2 is still just 0. And then here you would subtract 2 and divide by 3. Therefore, we have negative 2/3. So there's your two answers for that example. Okay, got